Hello and welcome students. In this lecture, I am going to discuss the concept of oxidation and reduction in terms of oxidation number. In the previous lecture, we talked about what is oxidation number and how do we calculate the oxidation number of an atom in any species, in a neutral molecule or in a polyatomic ion or in an element in its elementary state. So now we will apply the concept of oxidation number to define oxidation and reduction. So according to oxidation number concept, oxidation is defined as a process in which an atom undergoes an increase in its oxidation number. And what is reduction? According to this concept, reduction is a process in which an atom undergoes a decrease in its oxidation number. So oxidation and reduction, they are simply increase in oxidation number and decrease in oxidation number. For example, when sodium metal is treated with water, sodium hydroxide and dihydrogen gas is formed. Now if we look at the oxidation numbers of the elements on the reactant side and on the product side, we see that the oxidation number of sodium is 0 because it is in the elementary state. In water, hydrogen has a +1 oxidation number and oxygen has -2. Now on the product side, we can see that sodium has +1 oxidation number, oxygen has -2, hydrogen has +1. And when we look at the H2 molecule, the oxidation number of hydrogen is 0 because it is in the elementary state. Now looking at the reaction, we can see that sodium is undergoing an increase in oxidation number. And according to definition, increase in oxidation number is oxidation. So we can say that sodium undergoes oxidation in this reaction. Now see the oxidation number of hydrogen. On the reactant side, the oxidation number of hydrogen is +1. And in the product side, in H2, we can see that oxidation number of hydrogen is 0. So hydrogen is undergoing a decrease in oxidation number. And decrease in oxidation number is called as reduction. So in this reaction, sodium undergoes oxidation while water is undergoing reduction. Now you also know that the substance that undergoes oxidation is called as reducing agent, and the substance that undergoes reduction is called as oxidizing agent. So sodium is the reducing agent in this reaction and water acts as oxidizing agent. So in a similar way, we can find in any chemical reaction, we can find which substance is undergoing oxidation and which substance is undergoing reduction. Now, in order to explain this concept further, I will take some more examples. Now, here is a reaction in which sulfur dioxide reacts with nitric acid and forms sulfuric acid and nitrogen dioxide. Now, I have written the oxidation numbers of the elements above their formulas. You can see that sulfur undergoes increase in oxidation number. It means it undergoes oxidation, or simply we can say that sulfur dioxide undergoes oxidation, and the oxidation number of nitrogen decreases from +5 to +4. It means nitric acid undergoes reduction. So in this case, sulfur dioxide is acting as reducing agent, while nitric acid is acting as the oxidizing agent. In another reaction, methane undergoes combustion in the presence of oxygen and forms carbon dioxide and water. Here, carbon undergoes an increase in oxidation number from -4 to +4. It means carbon or methane undergoes oxidation, therefore it is acting as the reducing agent. Now, oxygen undergoes a decrease in oxidation number. Its oxidation number changes from 0 to -2. Decrease in oxidation number, it means it is undergoing reduction and is acting as the oxidizing agent. Now, types of redox reactions. Redox reactions have been classified into 4 types, that is combination reactions, decomposition reactions, displacement reactions, and disproportionation reactions. Now, starting from the first type, that is the combination reactions. In combination reactions, 2 or more elements combine to form a compound. 2 or more elements combine or react to form a chemical compound. For example, carbon undergoes combustion in presence of oxygen and forms carbon dioxide. In this case, we can see that carbon undergoes oxidation and oxygen undergoes reduction. So this is a redox reaction in which 2 elements, that is carbon and oxygen, combine to form a chemical compound. Similarly, when nitrogen and hydrogen gases are heated together in presence of some suitable catalyst, we get ammonia as the product. Again, we can see that nitrogen in this case is undergoing reduction because it undergoes a decrease in oxidation number, and hydrogen undergoes oxidation because its oxidation number is increasing. Now the second type is decomposition reactions. Decomposition reaction is the reverse of combination reactions. And in these reactions, a chemical compound decomposes and forms two or more components, and at least one of the components formed, should be in its elementary state. For example, when sodium hydride is heated, we get sodium and dihydrogen gas as the product. And in this case, the oxidation number of sodium decreases and oxidation number of hydrogen increases. So sodium is undergoing a reduction and hydrogen is undergoing oxidation. So this is a redox reaction in which a chemical compound is breaking down and is forming two products, two components, which are both in the elementary state in this case. Now if potassium permanganate is heated strongly, we get three products in this case: potassium manganate, manganese dioxide, and oxygen. There are three products, out of which oxygen is in elementary state. Now see the oxidation numbers. In potassium permanganate, manganese is in +7 oxidation state, and in the product side, manganese is in +6 and +4 oxidation state. So we can see that manganese undergoes a decrease in oxidation number, that is reduction, and oxygen undergoes an increase in oxidation number. Its oxidation number changes from -2 to 0 in case of oxygen, and therefore we can say that oxygen undergoes oxidation. So in the present case, potassium permanganate is undergoing a redox reaction in which it decomposes and forms three different products, out of which one product, that is the last one, O2, is in the elementary state. The third type is displacement reactions. As the name suggests, in these reactions, an element in a compound is displaced by another element. Now the element which is displaced can be a metal or a non-metal. So based on this, the displacement reactions are further classified into two types. Metal displacement reactions, and the second type would be non-metal displacement reactions. Now in the first case, in the metal displacement reactions, what happens? A more reactive metal displaces a less reactive metal from a compound which is usually a salt. For example, if copper sulfate solution is treated with a zinc metal, we get zinc sulfate and copper as the product. In this case, we can see that the zinc metal has displaced the copper metal from copper sulfate solution. It is because the zinc metal is more reactive. So a more reactive metal can displace a less reactive metal. When sodium metal is heated with magnesium oxide, we get sodium oxide and magnesium as the product. Now again, in this case, we can see that sodium, which is a more reactive metal, has displaced magnesium from its oxide, and magnesium is a less reactive metal as compared to sodium. Now coming on to the second type, that is non-metal displacement reactions. In these reactions, a non-metal is displaced. A non-metal atom is displaced from a chemical compound. For example, if sodium is treated with water, the product formed is sodium hydroxide and dihydrogen gas. Now in this case, we can see that the sodium has displaced hydrogen from water. Now again, we can see that sodium is more reactive than hydrogen. That is why sodium can displace hydrogen from water, and because of that, hydrogen gas is liberated. Similarly, if potassium is treated with water, we get potassium hydroxide and dihydrogen gas as a product. In this case also, a non-metal, hydrogen, is being displaced by a metal which is more reactive. Now in these two examples, we have seen that a metal is displacing a non-metal. It is also possible that a non-metal can displace another non-metal. But again, the condition is that the non-metal which will displace another non-metal, that should be more reactive. For example, if we look at the halogens like fluorine, chlorine, bromine and iodine, if we see the reactivity of these halogens, fluorine is the most reactive halogen, and the reactivity of halogens decreases down the group from fluorine to iodine. Now, if we have a condition like potassium bromide plus chlorine, if we have a solution of potassium bromide and chlorine gas is passed through this solution. Now we know that chlorine is more reactive as compared to bromine. Therefore, chlorine will displace bromine and the product formed will be potassium chloride and bromine as the product. So a more reactive halogen can displace a less reactive halogen. We can take another example in this case, like potassium iodide when treated with chlorine gas. Aqueous solution of potassium iodide is treated with chlorine gas, and what do we get? We get potassium chloride and iodine as the product. So again in this case we can see that a more reactive halogen has displaced a less reactive halogen, or we can say a more reactive nonmetal has displaced a less reactive nonmetal from its solution. Now the fourth type of redox reaction is disproportionation reactions. In case of disproportionation reactions, the same element undergoes both oxidation and reduction. That means the same element undergoes increase in oxidation number as well as decrease in oxidation number at the same time or simultaneously. Take for example the case of hydrogen peroxide. Hydrogen peroxide undergoes decomposition and forms H2O, that is water, and dioxygen. Now if we look at the change in oxidation numbers, we see that only oxygen is undergoing a change in oxidation number in this case. The oxidation number of hydrogen remains the same. Now the oxidation number of oxygen changes from -1 to -2, that is decrease in oxidation number when it changes to water, and the oxidation number of the same element, that is oxygen, changes from -1 to 0, that is the increase in oxidation number. So we can say that the same element, that is oxygen, is undergoing increase in oxidation number, that is oxidation, and decrease in oxidation number, that is reduction. So this is a case of disproportionation reaction. When phosphorus is treated with a base, a solution containing OH negative ions, the products formed are PH3, that is phosphine, and H2PO2 negative, that is hypophosphite ion. Now in this case, if we look at the oxidation numbers, we see that the oxidation number of phosphorus is changing and it is showing increase as well as decrease in oxidation number. When phosphorus changes into hypophosphite, there is an increase in the oxidation number, that is it is undergoing oxidation. And when it changes into phosphine, it undergoes a decrease in oxidation number, that means it is undergoing reduction. So such kind of processes in which the same element undergoes both oxidation and reduction simultaneously are called as disproportionation reactions. Now what are the conditions for disproportionation reactions? For a disproportionation reaction to occur, there are certain conditions. What are the conditions? The basic condition is that the element shows at least three oxidation states. Three different oxidation states or oxidation numbers should be possible at least, or more than that. For example, we saw in case of hydrogen peroxide, the disproportionation was taking place. And we also know that oxygen shows several oxidation numbers. It shows -2, which is one of the most common oxidation numbers. It shows -1 in case of peroxides, and in the elementary state, it shows oxidation number of 0. And we also know that in certain exceptional cases, it can show oxidation numbers of +1 and +2. So we can see that oxygen can show three or more than three different oxidation numbers. That is why it can undergo disproportionation. Similarly, when we look at the phosphorus, it also shows several oxidation states. And because it has capacity to show different oxidation states, more than three oxidation states, therefore it can undergo both increase and decrease in oxidation number at the same time. That is necessary for disproportionation reaction. Now we have to keep one thing in mind, that if an element in a reaction, during a reaction, is already present in its highest oxidation number or the lowest oxidation number, then it cannot undergo disproportionation. It means an element should be in an intermediate oxidation state. For a disproportionation reaction to take place, the element should be in an intermediate oxidation state so that it has a chance to undergo both increase in oxidation number and decrease in oxidation number. And if it is already in its highest or the lowest oxidation state, then it does not have the chance to undergo both increase and decrease in oxidation state. For example, I will explain it by taking an example of HClO4. In HClO4, chlorine atom is present in +7 oxidation state, and +7 is the highest oxidation state of chlorine. It means if this molecule HClO4, which is commonly called as perchloric acid, if it is undergoing a chemical reaction, the oxidation number of chlorine can show only a decrease, and it cannot show an increase in its oxidation state. Therefore, the possibility is that it will undergo only reduction, that is decrease in the oxidation state, but it will not undergo oxidation. Therefore, disproportionation reaction is not possible in this case. The reason is that chlorine is in its highest oxidation state. On the other hand, if the same element, chlorine, when present in zero oxidation state, is treated with sodium hydroxide, we get NaCl, that is sodium chloride, and sodium chlorate and water. Now in this case, the chlorine is undergoing both decrease in oxidation number and increase in oxidation number. Now, because chlorine was in an intermediate oxidation state, that is 0, from where it can undergo both decrease in oxidation number and increase in oxidation number, therefore the disproportionation reaction is possible. So this was all about the types of redox reactions. In the next lecture, I will discuss about the balancing of redox reactions on the basis of the concept of oxidation number. Till then, goodbye, and remember to revise the previous topics so that you would easily be able to understand the next topics.